Once you have that, you can add graphs for your circuit as well. So in order to do that, just go to the project, go to the graphs, just to new graph, and then what we want is a let's see, we want a rectangular graph. Yes, so let's create a rectangular graph, and in this graph we are going to add measurements of the scattering parameter. So just select the port parameters right here, select the S parameters right here, and we can have, since we want to see the scattering parameters S11 and S21, we would select both of them. So let's just add S21 first. Once you have S21, make sure that you have selected the magnitude here, and also it's selected to be dB, and then just click OK. So you have the scattering parameter S21 with the gain in dBs given right here. So just back to your simulation and just press this analyze button right here in order to obtain the graph. So as you can see, it's just a random shape as of now. Depending upon the parameters that you change within this RF circuit right here, you can obtain different graphs here. So I didn't specify all of the conditions for my filter right here. Otherwise, I could have obtained a graph with a cutoff frequency of a particular range or a particular point. So at the moment, it's just a random graph to give you an idea as to how to implement it. You can add markers in your graph as well to see the cutoff frequency as well as the band frequency of your filter and so on. Right, so one of the other tools that I want to show you is of this tuning tool right here. So what you need to do with this tuning tool is basically just select this button right here and select these parameters that you can tune. For example, you can tune width and length of each of these transmission line in order to make changes into graph as per your need. For example, I want to change the width of this particular T junction and the width and the length of this transmission line, width and length of this transmission line, and maybe width and length of this transmission line. You just go to the graph and then just select the tune button, and you have all of these parameters that you selected in your schematics right here. You can choose to increase and decrease it using the slider to see how they are affecting the graph. So for example, if you have some geometrical constraints and you have, or you also are required to obtain a particular cutoff frequency or band frequency within your filter, then you can use the tuning tool in order to keep a balance between those geometrical constraints as well as the filter specification. So at the moment I'm just making a random RF circuit, so I don't have any constraint, but just to give you an idea, these are all the parameters that are selected within the schematics, and I can use the tuning tool in order to see how changing the width or the length of each particular transmission line or T junction would affect my graph of the output. Right, so just use these two to tune your circuit, RF circuit, and as per the given geometrical constraints. Right, so once you have that, one of the other thing that I wanted to show you is to how to obtain the PCB circuit. So for that, let me just first select this button right here, view layout. As you can see, it's disorganized because it doesn't automatically rearrange all of these parameters. So what you need to do is you need to snap them together in such a way that they make sense when printed on a PCB board. Your lines would already be given to you, so you don't have to worry about that. You just have to rearrange them to make sure that they are bit organized on the PCB, right? So it looks very weird at the moment because obviously I made a random RF circuit. I would show you what an actual circuit would look like of an actual filter that I designed in another video that I would discuss in another video. But for now, it just looks something like this. So what you can do is just select all of these parameters and just make organized layout of all of them. By the way, you can also select this option right here. This option would basically just hold on a minute. So once you have this layout, you can also automatically snap them together. So it's basically automatically rearranging them. So in order to do that, just hold on to Control, select all of them, and sorry, just click on the Shift, hold all of them. Once all of them are selected, just um, press this button, snap together right here. So the program will automatically snap all of the available transmission lines or any of the RF mod components that you have automatically. Right. So obviously this looks very disorganized because I chose random width and height for all of the transmission lines as well as the T junction. But for a proper filter, I will show you in the next video how we obtain the similar proper layout for the low pass filter. Right. So once you have that, you can just go to the So once we have the layouts of the transmission lines and the T junctions and other components, we can go to the layout option, and here we can select which of the layers of our circuit or of our schematic we want within our PCB Gerber files. So obviously we don't need any of these layers. We only have layer 1 and layer 2. So we would deselect all of them um, and just select layer 1 right here and select layer 2 right here. Click on layer 2 and then you can basically draw a the grounding layer of your of just like this here and just make it, sorry again. So in order to draw the ground layer, you just have to select the layer 2 right here and select the shape of which you want to draw it. So I just want a rectangular grounding layer right here. So I would just make it ensuring that it covers the entirety of the circuit. So it should look something like this. So these are your components on the PCB and this is your ground layer. You can change the properties by selecting by right clicking it and choosing the shape properties, and here you can decide the width and height of your grounding layer and of your other components as well. Make sure it's efficient in terms of printing, because essentially we would be printing PCB, so you have to minimize the area of the grounding as well as the components in order to efficiently print the PCB. Select your width and height for of the grounding layer from the properties right here. So these are random as of now, as I said, because it's a random RF circuit, and I will show you in the next video as to how to create an actual low pass filter. Right. So once you have that, you can just go to the options, go to the drawing layers right here. Once you have that, you can just select the go to the file export mapping, select the Gerber file, and just select the ones that we have to print for the PCB, which will include layer 1 and it will include the layer 2. Right, so let us do because it's a Gerber file, so we'll have to import them separately. So first of all, do it for layer 1. Just select the Gerber map right here, select the layer 1 and select OK. Once you have that, go to the you can go to the layout and just export the layout.